Hello, welcome to Math 1314 video lesson, Chapter 1, Section 6. Section 6 deals with inequalities. When we talk about inequalities, we have three different representations. Representations of inequalities. Well, an inequality is obvious. We see this, the less than, greater than symbols. But there are three different ways we can write the final answer. The first way, we can write it as set notation. That's where we use the inequalities. We'll use the interval notation. Here we use parentheses, brackets, or a combination of the two. And then we have the graphical, which is simply a graph, and we either used open or closed circles, and we shade that region in. So here, let's discuss really quick the symbols we're using. We'll use either open circle or closed circles, parentheses or brackets, and inequalities. The difference between the two, if it's a solid or a bracket or with a line underneath it, these numbers are included. You can use the end numbers. The end numbers. An open circle or a parenthesis or that you cannot include. Cannot use the end number. What does that mean? Well, let's see. If I gave you this set, or if I gave you this set, or if I gave you this set, or if I gave you this set, each one of these represent a different answer. So since we're dealing with sets of numbers, that's where we use little squiggly lines. What is the answer here? We're going to talk about integers. Can we use 2 and 5? No. So our answer here are strictly 3 and 4. Graphically, we'd put here's 2, here's 5, open, open, arrow what's between there. 3, 4. Squiggly and squiggly. Can we use a 2? No. So we have 3, 4, but we can use the 5 because it's included. So we have an open at 2, closed at 5, and we can use anything inside there. I can use 2, 3, 4, but I can't use the 5 because it's a parenthesis. So there's 2, there's a 5, I can use everything inside there, which is 3 and 4. Likewise, this one I can use the endpoints, so it's 2, 3, 4, 5. which just means both endpoints are solid, and I can use everything between there. That's what the symbols mean. All right. So let's look at these now. Here's the chart. We're going to go through all of these. Again, if it's an open, then you use less thans or greater than with no line, or we'll use parentheses. If it's a solid dot, then that's when you have an equal to, less than equal to, or greater than equal to, or the brackets. So with this first one, let's look at the graph. I'm using everything to the right of A. These are my x's. To determine this set notation, we look at the endpoints, and look where x is. So we have A, x, and then infinity. X is to the right, so it's greater than A. Infinity is to the right, so it's greater than so. But since they're both solid, I could put equal to. So A is less than x, which is less than infinity. But this is redundant. I already said that x is bigger than A, so it goes on to infinity. So we just write this one, x is greater than or equal to A. If you flip these symbols around, make sure you keep the arrow pointing to the same number. Since it's pointing to the A here, it's got to point to the A there. So when we do the intervals, only use the endpoints. We use A, comma, infinity. You can never get to infinity, so that's always a parenthesis. Infinity and negative infinity are always parentheses. A is a solid dot, so it's a bracket. Okay, that's my x values. Wherever is shaded, that's my x value. Look at my endpoints. So I'm starting at negative infinity. Oh, as you read, left to right, I have x and I have A. So infinity is less than A is less than x is less than A. You can never get to infinity, so that's going to be a strict inequality. But A is included, so we can use that. But again, this is redundant because if x is less than A, then that means automatically whatever A is, it goes to the left. So less than left, greater than right. So the stress points, less than left, greater than right. That's right. So if it says less, this is x, it's going to the left, x is less than A. It's going to the right, so x is greater than A. Greater than, equal to A. So look at the endpoints. Negative infinity to A. You can never use infinities, but A is a solid. Just keep on going, and we can do the other ones. Remember, wherever you shade is your x. So it starts at A, it goes to x, there's all the x's, and it ends at infinity. It's an open circle, so I don't use the equal sign. I can never use equal there. Going to infinity is redundant, so x is greater than A. X is to the right of A. X is greater than A. Look at the endpoints of your graph. A, infinity. Infinity is always, so that's open, and that is a parenthesis. Let's go from the left. These are my x's. I go from negative infinity to x all the way to A. And these symbols are always inequalities. But again, this is redundant, so I start with A, go on X, then go to B. So, since they're both open, that's as far as I can go. So in the intervals, I simply go to the endpoints of my graph. There's my graph. There's my graph. And they're both open, so they're both parentheses. So those are the finite, meaning they have a beginning and an endpoint. The first one was infinite because it starts at a point and goes to infinity. Because that's what we call it. The first four are infinite. The next four are finite. Now we have four more that are infinite. Which this one means is start and go opposite directions. So these are your x's. So I start with negative infinity, go through x, and go to a. So I can close it. Likewise here, I go b, x to infinity, and I can use b. But the infinities are redundant. Let's just put extra stuff in there. So we have x is less than equal to a, but it could be here or it can be here, or x can be bigger or equal to b. There's that one. So whenever you go opposite directions, you have to have an or, because the answer could be in either one of those directions. Now for the intervals, now again, we're going to have two different sets. We're going to start at negative infinity, go to a. Negative infinity, go to a, which box. Then start at b and go to positive infinity. The symbol, the U symbol, means or. It's just a different form of using the word or in different symbol notations. Likewise, the next ones. Here are your x's there. here your x is there. Starts at negative infinity, goes through x to a. I can use a. Starts at b, goes through x, ends in infinity. I cannot use b. Again, the infinity parts are just redundant, so we have x is less than equal to a, or x is strictly greater than b. Look at the endpoints. Negative infinity to a. A is blacked out, so it's a bracket. Union, parenthesis b, comma, infinity. There's your x, and there's your x. Negative infinity, go through x all the way up to a. It's an open, so I can't use it. B, x, and infinity. I can use b, so I could put the line. I can use b because it's blacked out. Again, the infinity parts are redundant. X less than a, or x is greater than equal to b. Look at the endpoints. Negative infinity a, they're both parentheses, unioned with b, comma, infinity. I can use that, so there's that. And the last of these bidirectionals. Now remember, what this means is, because I have arrows both ways, if I pick a number, it can either be in here or it could be in here. That's why we use the word or. It can't be in both places at the same time. It can be and here. It could be greater than a, or and it could be less than b. It could be both. This is the and statement. But these are the ors. Negative infinity, less than x, less than a. B is less than x is less than infinity. X is less than a, or x is greater than b. That's what that means. So from negative infinity to a, parenthesis, union, parenthesis, b to infinity. So those are the bidirectional ones. When you have a point, a single point, x is between a and a. That's how you represent a point. One single number. If it's not a point, then we can represent it this way. X is between negative infinity and a, or between a and infinity. So x is less than a, or x is greater than a. It just cannot equal a. So in other words, that's going to be like that. And as we said earlier, if everything from negative to positive infinity if we ever have that, or if we ever have this negative infinity positive, we can just write R. It means the set of all real numbers. All right, now let's look at some examples. This is important also. So when solving inequalities, When solving inequalities, treat them the same way you would treat an equal sign. So solve them exactly the same way. No different. In other words, treat inequalities like equals. (4x plus 3 equals -9). Since it has inequalities, this is set notation. So let's put the answer in the other two other ways. So solve this. If that was equals, we would subtract 3 from both sides. So we have 4x is greater than equal to 9 minus 3 is 6. Divide by 4. X is greater than equal to, well, that can be simplified. 2 goes into 6 3 times, 2 goes into 4 twice. So our final answer for the set notation is x is greater than or equal to 3/2. All right. So I want the other two ways. We have the graphic and interval notations. Whenever you're converting from one to the other, always, it makes it easier, but you don't have to, but it makes it easier if you go through the graphics first. It's equal to, so it's, and since x is on the left-hand side, the arrow is pointing to the right, that's the direction you shade. It goes to infinity. So the interval notation, look at the endpoints. Since that's solid, there's your answer. All right, let's look some more. Three minus 5x is less than 4. Again, treat it as though you're solving for x. So subtract 3, get rid of the solid numbers first. We're trying to get x by itself. So we have negative 5x is less than 4 minus 3 is 1. Again, same as last time. Whenever you have a negative in front of your x, change everything across the board. Change the sign there, change the direction, and change the sign there. So it becomes positive 5x, change the direction, -1. And divide by 5. So x is greater than -1/5. The answer is -1/5. It's an open circle, and it points to the right, so it shades to the right. So we start at -1/5. Go to infinity, and it's open, and there's that. So whenever you have a negative in front of your x, remember I said change everything across the board. Now that we have inequalities, it changes that direction. Let's do another one. Less than or equal to 3 plus 7x. We're solving for x. Get rid of the 3. Since it's -3, we add 3. 4 plus 3 is 7. 7x. Divide both sides by 7. 1 is less than equal to x. Okay, now it makes it easier when x is, it doesn't have to, but it makes it easier to graph. When x is on the right hand side, you can flip the entire equation. Flip everything. So there's the arrow is pointing to the 1, so it's got to point to the 1. It has to remain to the 1. So here's 1. It's a solid, and it points to the right, so it's this way. To infinity. If it goes to the left, it's negative infinity. So there's the graph. These are my endpoints. Bracket, because it's closed, parenthesis. Alright, let's try some fractions, because we know we love them so much. Again, you treat them the same way, the same rule we talked about earlier. We have that. Whenever you have fractions in an equal sign, there are 5 steps. First, find the LCD. In this case, since they're all different numbers, multiply them. 2 times 3 times 5. 2 times 3 is 6 times 5 is 30. That's the LCD. Multiply LCD to each term. So we have a term here, we have a term here, and we have a term here. So I put the LCD in front of each one of those. 30 times 1 over 2 plus 30 times 3 over 5 less than 30 times 1 over 3. Whenever you have fractions in multiplication, always reduce before you multiply. Also, keep in mind where our LCD came from. 2 times 3 times 5 became 30. This is important for the next step. Now, the fractions cancel with the LCD. So if you cancel the 2, how many times 2 go into 30? Well, get rid of the 2. 3 times 5 is 15. How many times does 5 go into 30? Well, block the 5. 2 times 3 is 6. How many times does 3 go into 30? Well, block off the 3. 5 times 2 is 10. That's the easiest way. That's why we'll make sure you keep a track of how you find the LCD. So let's write what we have. 15 times 1, 6 times 3x, less than 10 times 1. Step 4 is multiply to get rid of the parentheses. Multiply to get rid of the parentheses. So 15 times 1 is 15. 6 times 3 is 18x. 10 times 1 is 10. Now solve. We're solving for x. Subtract 15 from both sides. So we have 18x is less than, 15 is bigger than 10, so it's negative. 15 minus 10 is 5. Divide by 18, so x is less than negative 5 over 18. draw the graph first. Here's negative 5 over 18. Arrow is going to the left. It's an open circle, so it's going this way to negative infinity. So look at the endpoints, reading left to right. Infinity is always open. That's an open circle, so that's there. All right, let's look at another one. We're going to keep doing a bunch of these. Here's another type. These are called tripartite. 3 parts. Negative 5 less than 4x minus 3 is less than equal to 9. There are 3 parts. Hence the tripartite. But remember, we're only interested in solving for x. So this is the only part that we're concentrating on. Whatever we do here, you do to the other 2 sides. Again, when you're solving for x, whatever you do to this part of the function, you do to the other 2 sides. So here's a minus 3, so you add 3. That means you add 3 to the other ones. Negative 5 plus 3, negative 5 is bigger, so it's negative. 5 minus 3 is 2, less than 4x, less than equal to 9 plus 3 is 12. Need to get x by itself, so I divide by 4. Negative. 2 and 4 can simplify. 2 goes into 2 once, 2 goes into 4 twice, so it's negative 1/2. The 4's cancel, so it's just x. 4 goes into 12 3 times. And there's your answer. So negative 1/2, 3. That's an open, that's a closed, and x is between there. So look at the endpoints. That's a bracket because it's solid, and that's a parenthesis. Okay, let's look at another one. This time with fractions. 3 over 2 plus 5. Remember, treat the inequalities the same way you do an equal sign, which means you have to find the LCD first. The LCD of 3 and 5, 3 times 5 is 15. Multiply the LCD to each term. So there's a term, there's a term, there's a term. So I'll put 15 in front of each of these parentheses. X plus 2 over 5 less than equal to 15 times 4. Third step, reduce, cancel. This is where you get rid of the fraction. How many times 3 go into 15? Well, if you get rid of 3, you have a 5 left. How many times does 5 go into 15? Get rid of the 5, you only have a 3. So we have 5 times 2 is less than 3 times 3x plus 2 less than equal to 15 times 4. Step 4 is multiply to get rid of the parentheses. 5 times 2 is 10. 3 times 3 is 9x. 3 times 2 is 6. 15 times 4 is 60. All the parentheses are gone. So solve. Again, we're only interested in the middle. So we get rid of 6. We have to get rid of 6 on all three parts. 10 minus 6 is 4. The 6's are gone, leaving me with 9x. 60 minus 6 is 54. Divide each term by 9, which gives me 4 over 9 less than equal to x, since the 9's cancel. 9 goes into 54 6 times. Here's a hint. We know 3 goes into 9. Do we know that 3 goes into 54? If you take 54 and add the numbers individually, you get 9. If this number is divisible by 3, then this number is divisible by 3. So 3 goes into 54. 3 goes into 5 once, with 2 left over. So you have 24 on top. So 3 goes into 24 8 times. But 9 is made up of 3 times 3. That's the first 3. So there's one more 3 left. Does 3 go into 18? 1 plus 8 is 9. Yeah, so we know 3 goes into 18 6 times. That's just a trick of the trade. If we graph this, 4 over 9 and 6, they're both solid circles, and x is between there. 4 over 9 to 6, the endpoints, they're both brackets. All right. Negative 5 over 3 is less than 3 over 4, 2 minus 3x, 5 over 3. Anyway, fractions and equal signs, so we have to find the LCD. Since the only bottom numbers we have are 3 and 4, the LCD, multiply together, we get 12. So put 12 in front of each of these terms. This is one big equation in here. And then the last one. Let's multiply. Step 3 is reduce. 3 goes into 12 4 times. Again, if you get rid of 3, there's 4 left. 4 goes into 12 3 times. If you get rid of 3, you have, if you get rid of 4, you have a 3 left. And last one. 4 times negative 5, 3 times 3 times 2 minus 3x, 4 times 5. Multiply to get rid of the parentheses. Positive times negative is negative. 4 times 5 is 20. We'll do this one twice. 3 times 3 is 9. Leave the parentheses alone. 4 times 5 is 20. We're not done because we have some more parentheses. So negative 20. 9 times 2 is 18. minus 9 times 3 is 27. We're trying to get x by itself, so we have to get rid of the 18 first. It doesn't have an x, so we subtract 18 from everybody. They're both negative, so the answer is negative. So we add the numbers. 20 plus 18 is 38. 18s are gone. Negative 27x less than. Opposite signs, 20 is bigger, so the answer is positive. 20 minus 18 is 2. There's a negative. So we change everything. Change all the signs and the directions. So negative 38 becomes positive 38. That less than becomes greater than. That negative 27 becomes 27x. That less than becomes greater than. That becomes negative 2. This looks weird because the negative is to the right, so we could flip the entire equation over. I'm going to put the negative 2 over here. 27x stays in the middle. I want that 38 over here. So between 38 and 27, it's pointing at the 27. Between 27 and negative 2, it's pointing at the negative 2. And divide by 27. So we have negative 2 over 27 less than x less than 38 over 27. Alright, so my battery's going low. We'll call it there. I'll put some more up there a little later. Alright, good luck everyone.